All right, this question is not written as thoroughly as it should be. I read over it and I think, what was I thinking? We really should add in here that f of x is continuous and differentiable. So we're assuming what we need for mean value theorem, that f of x is continuous and differentiable for x between 2 and 7. Then my mean value theorem tells me that if I do f of 7 minus f of 2, divide by 7 minus 2, that's going to give me, at some point, that will be equivalent to my derivative, so some f prime of x. But we've been told that that's always going to be greater than or equal to negative 2. So simplifying this, I'll have f of 7 minus negative 4 over 5 is greater than or equal to negative 2. My f of 7, negative 10 minus 4, will be greater than or equal to negative 14. So my minimum value for f of 7 is negative 14. Let's look at this other application of mean value theorem. This one, we've got a car traveling below the speed limit of 70 miles per hour, passes a police officer at noon. So I'm going to let t equals 0 be at noon. And maybe it's midnight, I don't actually know. At 12:20, so time equals 1/3. The same car passes another officer 24 miles further down the road. So if we let that happen and we let f of t be equal to distance, then f of 0, that's going to be where I start my, where I first pass the police officer, so my starting point. At 1/3, I've gone 24 miles. So mean value theorem tells me that my derivative, that at some point between the 0 and 20, at some point in that 20 minutes, my mean value, at some point I'll have a derivative that's going to be equal to 24 minus 0 over 1/3 minus 0. That's 72. But if my function is distance, my derivative is speed. Therefore, at some point, I would have reached a speed of 72 miles per hour, which is greater than my 70 mile per hour speed limit. Therefore, you were speeding at some point in the journey.